Live from New York, it's Ask an Engineer.
Hey everybody, and welcome to Ask an Engineer. It's me, Lady Ada, the engineer, with me, Mr. Lady Ada, on camera control. We've got a fun-filled 1-hour show for you tonight, all about making and hacking and coding and soldering and sewing and being creative and making stuff with your hands. So put down your phone, unless you're watching us on the phone, and join in the Maker Fund. Mr. Lady Ada, why don't you tell them what's on
That's
today's
right.
show?
Deals and surprises and more ahead. New RGB is the code, 10% off the Adafruit store all the way up to 11:59 p.m. Eastern Time. User lose it. Come on by and save a buck or two. We'll talk about some of our live shows. Show and tell just happened. Thank you, Liz, for hosting. We'll talk about Desk of Ladyada, which we do every Sunday, including Great Search. We got JP's product pick of the week. We'll play the highlight video. We'll have a little bit of a reminder about JP's show tomorrow. We have advanced manufacturing made in New York City factory footage, a glimpse of the things that we make here in New York City at Adafruit. We got some 3D printing videos. We got Iron and PI brought to you by DigiKey. This week it is
Hero say.
Hero Say. We're going to do a little bit top secret. We got some new products. We're going to answer your questions. We do that on Discord, adafruit.it/discord or discord.gg/Adafruit. Come on by, ask your questions and more. It's called Ask an Engineer for a reason. And
I'm an engineer. Ask me stuff.
we do a ton of questions at the end, and we do some throughout, of course, but you can stay around 24/7. Ask your questions.
Yep.
All that and more on, you guessed it, Ask an Engineer. Okay, reminder, new RGB is the code. You get free stuff too.
Yes,
Where
when
are
you
they
order from adafruit.com, it helps support us and keep all the code and open source hardware and tutorials and more, all the goodies going. So please do. And we'll give you some free stuff too to sweeten the pot. So $99 or more, you get this beautiful PCB coaster made with gold coat PCBs with an Adafruit logo on it. $149 or more, you get a free KB2040. It's an RP2040 microcontroller board that is Pro Micro pinout compatible. So it's a great upgrade for your Pro Micro projects, but now it has a powerful dual core Cortex M0 chip with 8 megabytes of flash and USB-C and STEM QT and buttons and pixels and everything. Great for all sorts of projects. $199 or more for UPS ground shipping in the continental United States. And we still have $299 or more Circuit Playground Express, our favoriteest round circuit board ever with the SAMD21 on it. You can use it with Arduino or CircuitPython or MicroPython or Code.org. CS Discoveries. It's a great way to learn electronics and coding with physical computing. And no soldering is required. You get everything you need is built in.
Yeah, and someone just asked, are the cutie pies on sale for Valentine's Day? Yes, of course they are. Just use the code.
Oh man, that's a good idea. We should have thought.
Yeah,
Well,
that's and all this.
yeah.
Sure.
But they're on sale, 10% off.
Yeah,
For Valentine's Day.
Yeah.
Yeah, we did that on purpose.
Yes. I mean, yes.
Yes.
On Monday, it's a Adafruit holiday for the team, so it's also a federal holiday. So if you place an order on Monday, it might not ship till Tuesday. That is just a reminder. It's President's Day. Adabox is shipping.
How many have we shipped?
Over 1,000. So
1,500.
yes, so that is over 1,000. So thank you everyone for your patience. We made our announcement that we would be shipping Adabox in 2023. We got a few out the door.
Where's all the people always ask, where's the Adabox? With Adabox? Wow.
Yeah. So you can go to adabox.com. We put updates there. We're getting most of them out in February. We have our unboxing that'll happen in March. Look for the announcement.
We're shipping hundreds a day.
Yeah, and full speed ahead. So thank you everyone for your patience. We got a few out at the end of 2023, and then it's only been about a month-ish, and we got them out. So after a very long COVID time period and then part shortage that impacted the world, it was very difficult to ship any type of electronics. We redesigned over 700 products, including our Adaboxes.
Twice.
Oh, someone got their Adabox today. Thank you so much. Yeah, keep it a secret. There's kids watching.
Yeah.
So thank you so much, everybody. We really appreciate it for your patience. When we ship the Adabox, if your credit card needs to be updated or your address, we'll let you know. And we will hopefully be able to ship the next one,
3 months.
3 months from now, we'll see. We do a bunch of live shows. I just finished up the show and tell right now. Thank you so much, Liz. We're gonna watch the show and tell once we get off air. We do the show and tell every week, 7:30 p.m. Eastern time. Come by, show all your stuff, whether it be your makerspace, hackerspace, retro stuff, cool books, just anything to learn and share the idea of making stuff together. That's what show and tell is all about. Longest running show and tell. It's like 15 years now. Come on by. The link is in Discord every Wednesday at 7:30. And
We
you
were
can
just
join
saying, and
in.
next year will be 20 years old.
Yep. And we've done a show and tell just about every week since the technology has allowed it.
You can't tell, but we're still 25
Something
at
like
heart.
that. Yeah, I think the shirt is 25 years old. So we also do a show on Sundays, Desk of Ladyada. It's in two parts. Ladyada, what did you show off for part one?
Okay, so had a bit of a cold last week, so did not get a ton of new hardware done. But I did do some more work on Flopsy. And I got it working with Arduino. So I'm trying like going back to code that like was working a year ago and being like, does it still work? Which is like not always true, right? So you have to test it. So we got some of the demos working for Arduino code with the floppy disk reading. And then today I was actually chatting with Jepler about how we're going to implement floppy disk writing. So you can write through Greaseweasel, which I have to do next, but you can definitely read. And one of the demos is that you plug in the board into USB and it shows up like a floppy drive, which is kind of cool. So I talked about that, and then I also talked about some updates I'm going to be doing where I add Apple Disk 2 interface support, and also index sensor support.
Okay. And then we also challenge our Lady Ada to show us how to use DigiKey in the best possible way because there's billions of parts on there. What did you show during the Great Search this week?
Okay, so I had coffee, but didn't do anything. So for the index sensor for the floppy drive, I want to be able to like sometimes tell when the floppy motor has rotated 360 degrees, and so I'm going to use an optical sensor. To make it mounting easy, I want to have an optical sensor that is like right angle. So I have the PCB, and then I want the sensor to point out over the edge of the PCB. So I want to find a right angle analog reflective light sensor. And turns out there's only one available in DigiKey, but we found it and it's a good price and it's a lot of it in stock. So check it out. If you ever have to do reflective sensing, I think the one I picked is pretty good.
All right. And then on Thursdays, we do JP's workshop. Here is this week's highlight.
DS3231 Precision Real-Time Clock Breakout. This has I2C to communicate with your microcontroller. It has a battery backup, so it's always going to keep track of the time, even when your project is powered down. And it has the STEMMA QT connectors to make it plug and play with your microcontroller projects. So the crystal is sitting there oscillating, but the temperature can change that oscillation. So it has a temperature compensation, so it can adjust the time that it's reporting based on any changes in temperature. And I'm going to plug that STEMMA QT cable into my real-time clock. It's going to power up, and then it is immediately going to grab the time off of the chip. So I set this chip yesterday while I was setting up this project with the time, and it has just been sitting there continuously running and calculating that time. So it just updated, and now here we are, 1:13 and 30 seconds. DS3231 Precision Real-Time Clock Breakout with STEMMA QT.
And don't forget, JP's workshop is tomorrow, and then on Friday, it'll either be Scott or Tim on Deep Dive, Fridays at 2 p.m., 5 p.m. Pacific. Let's do some Python on hardware. All right, so we have our Adafruit Daily newsletter. We do this every single week. You can go to Adafruit Daily. You can get it via RSS. You can get it on GitHub. You can get it sent to you via email. Completely separate site. We have our highlights of Python on hardware projects. This is a submarine hunting game.
Cool. Yeah.
With CircuitPython. We have how to fail at CircuitPython. This is a very cool
This is from
guide.
Playground.
Yeah, this is
Which
Playground
forget
guide.
people post your projects on Playground and we
Yeah,
highlight them.
Playgrounds.
And like there's a bunch of it, and like Squid, who I think is in the chat,
Yeah,
posted a project.
This is
and
super cool.
It's live, and how to check code failures
yeah.
on CircuitPython.
We want to have
So
the easiest, best place for you to post your projects. You don't have
How's
to
that?
worry about ads or forcing people to log in to see stuff. But anyways, one of the things that we like to do is cover kind of all the ways to run Python on hardware. So we have this Raspberry Pi 5 review from PC World. I'm going to get to this other things in a second. But one of the things that is in the news right now, and I thought this would be kind of funny, and when I asked Ladyada what does she want to talk about for this week, um, she said, "Oh, I'll talk about one of the articles we linked to, which is here's Raspberry Pi alternatives." Now, we didn't time this or anything, but the meme that's going around, which I think is interesting.
There's a meme.
There's a meme that's going around. I think this is interesting, and then I'll bridge the gap here. Um, so there's the Apple Vision Pro that came out, and
Yeah.
then there's the Meta Quest, and I think each company has their own thing, and each company has their own figurehead. There's Tim Cook from Apple, there's Mark Zuckerberg from Facebook. Google has their guy, Microsoft has their guy. So
Who's the guy?
their guys,
Pinchot?
yeah. And so the interesting thing is Mark Zuckerberg just did like a very like I'm gonna say Adafruit style video, which is like the founder talking about stuff. It's like so Mark Zuckerberg
Like Ask Zuckerberg.
so sort of ask a Zuck. So what I thought was interesting was that just with like kind of not maybe they spent a lot of time on it and it made it look like it was like off the cuff, like not edit, but it was like he's like, okay, here's someone, they're just going to record me and they're going to have, and I'm going to talk about the Apple Vision Pro and what I like about it and its strengths and weaknesses and all
That's
that
actually
stuff.
really cool.
Yeah. And I thought how interesting it was that the CEO, the founder of Facebook, would do that because Tim Cook from Apple is not going to
They already do that.
he's not going to say, hey, I tried the Quest, the Meta Quest, and here's what I think about it. It's just different style.
Totally.
But I thought it was interesting that like Mark Zuckerberg is using the Apple Vision Pro, and he's like, hey, this is why I think the Meta Quest is better, and he gave complimented his competitor and did the strengths and weaknesses. And so I don't get a chance to talk to the Raspberry Pi folks that often, but I actually think Eben from Raspberry Pi should do something like this because I actually think he has the ability to talk straight to the camera and say, well, here's what's good here, and admire competitors, all that stuff. I think it'd be interesting for Eben to say, hey, here's the Raspberry 5, here's the Raspberry competitors out there, here's what's good with them, here's other things, because I think that's kind of where we're at. There's the companies that they need the polished videos and they will never do the comparisons, and then there's some people who can look in a camera who really know it, and what matters most of the time is the founder that gets their hands dirty. And so I think that's why like Mark Zuckerberg was able to do this comparison with Apple Vision Pro and Meta Quest because he's kind of you can tell that he's really into this stuff. Not that Tim Cook isn't, it's just different. So when Lamar said, oh yeah, I'll talk about the 5 best Raspberry Pi alternatives in 2024, it's not because we don't like Raspberry Pi. It's just this is interesting for us. And we also
like there are some things that are, if you want,
yeah,
like,
we'll tell you.
GPU powered
yeah.
AI, like
and,
the NVIDIA is going to.
And of course, we're going to recommend Raspberry Pi 5 stuff, for what makes sense. But I think that's one of the differences. Like companies, there's companies that founders that are technical founders that are going to be able to talk to people, and some people like that style, some people don't, whatever. But I think this will be interesting. So when this came up, you're like, oh yeah, I'll talk about the alternatives. So Ladyada, take it away. There's other there's Raspberry Pi alternatives.
Yeah.
We have a blog post and sums it up thusly.
Yeah, there's a whole article. But what I think is interesting is, well, first off, I've used some of these, and like you're not going to have as much support as with the Raspberry Pi. I mean, like the Raspberry Pi, like it is just there's millions of users, and so there's more support, there's more projects. But the Orange Pi is like really, really popular. Can you scroll down? It's
Do you want me to go to the article?
Used. No, you can just. Those are fine. Yeah.
Okay. All right. First on Orange Pi.
The Orange Pi. And you'll see like some of these have like different things that you can like that are add on. Like it looks like there's like a built-in battery on this one. It has a smaller connector. It uses the Rock chip. Okay, scroll down.
Okay.
And a lot of these, like some of these actually could like run Windows and stuff. The UDO Bolt, and I think it has like 2 PCI slots, or no, it has ECC RAM, so you can actually add like a significant amount of external RAM. It has like looks like Grove connectors on the bottom. All right, so then go down. There's the Leap Potato, which
we're going to tie this all together with CircuitPython in a minute.
Yeah, and this
Hang
one,
tight.
I think this one is actually like open source hardware. This is the Amlogic, which is also used by I think the Orange Pi. This chipset, and it's like hardware compatible, and it has the 2x20 header. It looks like it also has infrared input. And they kept the AV output, which is kind of nice, and they have a serial port, which is kind of nice console. And then the Odroid, which is like really a beefy processor, that looks like it's a real-time clock, audio output built in, infrared as well. So a lot of these are good for like media servers or external control. This also has a DC power input, which is kind of nice. You want to power it from not USB, from a DC power plug. Looks like it has a buck converter, so probably can handle it. And of course, the NVIDIA Nano, is for you want GPU performance and you want to do AI. This is definitely going to have. It's basically the equivalent of like, basically, look at the specs, but Raspberry Pi plus a coprocessor Coral type
That was their pick.
device.
Now, the thing that's a challenge though is for microcontrollers, you kind of have to have a different programming language, a different thing. But one of the things,
Oh, by the way, all these have different hardware interface layouts.
all of these are very complicated, except for we kind of knew this was coming. So one of the things we have is we have
I think 4 out of 5 of these are on Blinka already. So if you go here and you type in like orange, you see we have all the orange pies. So
yeah,
the 5, the 5 plus, the light, the 1. So these are supported with Blinka. And so, if you want to do GPIO, I2C, SPI, and use all of our libraries, we have like hundreds and hundreds of libraries.
yeah,
A lot of example code will just work out of the box. Now, not everything will work, because like sometimes they have like very specific weird interfaces
yeah.
for stuff, but a lot of the basic GPIO and hardware interfacing will work. If there's analog or PWM support, we usually have that as well. And we have guides, especially for the Orange Pi, and you can look for the NVIDIA Jetson Nano. We have support, and we try to get it so that you can use sensors, displays, OLEDs, no matter what Raspberry Pi compatible, incompatible, Linux, single board computer you're using. And that's like a big deal, because it didn't, like, believe me, when we did the initial port for Blinka, that was not true. A lot of them, they all have their own little like weird ass GPIO hardware interfacing forks that are like
Yeah.
fork of a fork of a fork, and they like tweak some like register values, and then they're like, ship it.
So in summary, one of the things that I think is important is like, especially when you're in this like maker world and you're like Adafruit, like we're always going to do open source and we want to make something. So whether you pick a Raspberry Pi or an Orange Pi or NVIDIA, you'll be able to use Blinka. And if there's, whether it be a supply chain issue or it's just right tool for the right job, we'll always recommend the right thing. So
yeah, just try to make it's compatible in a hardware, like, and this was a big deal. Like, when I did this talk like 4 years ago for, Australia Linux conference. And I was like, I don't want to keep writing drivers for every interface. And then the thing is, like, stuff in the Linux kernel changes, like they do change stuff. We can hide those changes behind
So
this
I don't know if I'll get time, but one of the things I thought would be funny and useful is like, oh, hey, I mean, just like go to that Digitrends or get L5 and just do the same thing that Zuckerberg did. Because I like that there's some, Evan's very technical. I like that there's some founders that can do that. And I think that's what people want to see more and more. Like the beautiful marketing videos and like, okay, you're going to watch Marvel movies with, this thing on your head. Okay, cool. But I like the idea that someone was like, well, here's the actual tech specs. Here's the thing. Here's what here's the, like kind of in the weeds. In one video take live. We're doing this live. But anyways, I thought that was interesting.
This is live?
Yeah. So
they saw me yawning?
Yeah. So anyways, check out that and more. It delivers to you every single week at Adafruit Daily. That's what we're all about.
Thanks, Blinka.
All right, let's do some, speaking of open source and more, Ladyada, we do open source hardware. We have a bunch of guides. What's on the big board? We have almost 3,000. We're up to like 2,900 and like 80 something, I think.
Yeah.
We're going to be celebrating 3,000 guides soon.
Okay, so let's start from the top. So top left, so the Memento focus stacking. So 2 weekends ago, JP and I were like, can we, the Memento camera, the open source hardware camera that we designed, can we control the autofocus to manually focus in and out? Like, there's an autofocus mode, but can we manually focus and like step through the voice coil? And the answer is, after like a couple hours, yes. And thankfully also wrote some code the previous weekend for time lapse that did locking of the white balance and the exposure, so that like it wouldn't like auto exposure fix and like you'd get flickering. So JP wrote a great guide for focus stacking, and I don't know if you added a video or not, but you can do, so this is a picture of flowers, and it's a macro photo, and normally only one piece can be in focus, but with this you can take 50 photos and then you use like free online software and it squishes it together and auto focuses everything. You can also do dual focus where something nearby and far away is in focus, which is like used in horror films a lot, and also can do focus panning, so like uh tracking through a shot and like focusing on different elements. So basically, like, usually you don't get to mess around with the autofocus or the manual focus on a camera programmatically, but you can with Pixel's hardware. Aaron did a guide on this really cool
Play
WLED
video.
controlled matrix using Monster Fur. We'll do a video about that. We did a guide for the BFF, the DC Power BFF. So if you have a Cutie Pie board and they're very popular, you want to power it with up to 20 volts DC, battery packs or DC power supply, and you want to like use that for motor control, or you just want to like be able to power your BFF from everything, not just a USB-C. This is that's a buck converter, so it'll be very efficient. All right, then scroll down. Then we've got from Liz. I think we do have a 1-minute video
Yep,
about this.
we're gonna play 2 videos. 3 videos today.
What's the deal with the sushi conveyor belt projects from Japan? I don't know, but I love it. So we got these bar displays. We got the Qualia. Let's show how to make a sushi conveyor belt in Arduino. Also shows you how to use Platform IO with the Qualia board. So if you want to do like intense projects that need C or Arduino, you don't want to use CircuitPython. Like this definitely benefited from that, because controlling that display uses the PSRAM, which means it's you need to be using C code if you want to get really good performance. But Liz did an excellent job, and Noe also printed out this beautiful sushi nigiri case for it. So like I don't know why, but it's cool. Also got this gorgeous kind of art deco.
Yeah, and I'm
clock.
gonna play this clock tonight too.
In a box unboxing guide. We're not talking about that.
No.
It's a secret. And then I think the CircuitPython text editor on the go phone was last week. So there you go. That's the guides this week.
All right, let's play a couple videos and then we'll do some New York City factory footage, and then we're gonna do 3D printing. So I'm just gonna go video to video to video. Then we'll see you on the other side for INPI.
Okay.
Take it away, team.
Bye.
Make your own petable, programmable art piece with an Adafruit Feather ESP32 and a custom-built grid of LED strips. Control it with any Wi-Fi enabled device. Setup is quick and easy with the free open-source WLED software, which gives you hundreds of animations and color combos. This is a fun project with no coding, but a little tricky soldering work. You'll love creating patterns for your new furry friend. See the full build tutorial at learn.adafruit.com. And remember to subscribe for more fun DIY electronics projects.
And here's some factory footage. And that is how it is made. Let's do some 3D printing. We're going to roll right into the next one, and the next one, the next one, the next one. We got 2 back-to-back videos. We're going to do the clock, and then we're going to do a speed up. Take it away, knowing Pedro.
You can build a lovely digital clock with a large 7-segment display, a Feather RP2040, and CircuitPython. Thanks to Stemma QT connectors, no soldering was required for this plug-and-play design. This project features a 1.2-inch 7-segment LED display powered by the Adafruit Feather RP2040. For timekeeping, this uses the DS3231 real-time clock module for precise and accurate timing. A rotary encoder is used to set the time, making those daylight-saving time changes quick and easy. It also has an auto-dimming feature which lowers the display's brightness so it can be bright during the day and dim overnight. The 3D printed enclosure design is inspired by mid-century modern clocks that look both elegant and minimalistic. The enclosure snap fits together and can be 3D printed without any support material. We think this is a fun CircuitPython project for beginners or a starting point for seasoned makers who might want to add more features. The CircuitPython code has user configurable settings, allowing you to set a minimum and maximum brightness depending on the time of day. You can initially set the real-time clock module to match your current time and save the code to program the module. To adjust the time, the rotary encoder is used to set the hours and minutes by doing a long press and turning the knob. The code takes care of converting the RTC to display 12-hour time on the 7-segment LED display. The Feather RP2040 and the DS3231 RTC module are secured to a PCB bracket, and everything is connected with Stemma QT cables, making this project plug and play. A light diffusing gel filter helps to dim the brightness of the LED segments, making them appear much more crisp and legible. Our CAD models are open source and free to download, so you can modify them or reuse the parts in your own projects. We hope this inspires you to try CircuitPython for your next electronics project.
And that's 3D printing for the week. Thank you so much, Noah and Pedro. Don't forget every single Wednesday, 3D Hangouts. Noah and Pedro, the longest running 3D printing show in the known universe. For good IFPIA, the code is NEORGB. It all
I
makes
think
sense.
the James Webb telescope is going to like find some older.
Yes, we'll
printing
find
video.
another one.
Okay.
Let's do an MPI.
On MPI.
Hi, on MPI, brought to you by DigiKey. This week it is Hirose Ladyada. What is the new product introduction of the week this week?
Okay, so this week we're going to be talking connectors from Hirose. And I thought actually, like, this is Valentine's Day and we're doing the stream. And so
Oh,
one thing I thought was people often ask, how do you pronounce the name of this company? Is it High Rose? The answer is no. It's Hirose. Just think of David Bowie,
Oh.
Heroes. Hirose. And you probably know this company, even if you don't know this company, because they are the ones who invented the UFL connector, which is basically used for all RF devices. It's a really well-designed connector that allows you to connect up to, I think, 5 or 6 gigahertz antennas on a pick-and-placeable connector that is reconnectable multiple times. I looked up the patent. It was in 1993 with a beautiful diagram. So Hirose is, they've been known for a very long time for making very high quality connectors. But this week we're going to talk about the connector, the DF40 series, which we first saw on the Intel Edison. If you remember the Intel Edison,
I do.
on the bottom there, they had a connector, and this was a like very small single board computer that I think it predates the Raspberry Pi. And it had a connector that would let it connect to a main board. We actually carried the connector, and we carried boards that would plug into. And then more recently, it's been used on the Raspberry Pi compute module. So, this is single board Linux computers seem to like this connector. So on the bottom of the CM4, the CM3 was like a SIM, like a memory out format, but there weren't enough pins. On the CM4, there's two 100 pin connectors, and then you can connect it to this main board. And what I think is interesting about this is that these two connectors are the only connectors for the compute module, and yet you get two HDMI outputs that I think can do like 4K a piece, Ethernet, USB high speed, micro SD card with like high speed SDIO connectivity, power PCIe. You can do DPI TFT display output, two uh, CSI camera connectors, and two DSI connectors. So like a lot of very high speed data interfaces, multiple video camera, Ethernet interfaces, but also and PCIe, but also the power for the module is comes through these connectors. By the way, if you want to create your own, Sean Himmel with DigiKey did a great tutorial on creating your very own breakout board for the CM4. So, when you look at the specs for this connector, what's really neat about this connector is it does like a lot, like it does more than you expect. Like, for example, it can do up to 30 volts AC or DC. So like most connectors that are that small and fine pitch, maybe they're rated for like 6 volts, 12 volts or something, but this can go up to 30. And the rated current is also pretty high, 0.3 amps. I'm assuming that's per pin. And then of course, if you need more current, if for the CM4, you need more current, like 2 or 3 amps, because of the processor you have. You just have multiple pins in a row. You have like 4 power pins or 4 ground pins, so you can basically triple the amount of current. And then the performance is it's actually spec'd for USB 3.1 MIPI SATA PCIe with a transition rate of 10 gigabits per second. So it's designed for high speed and high power, and it can do high current, which is where like you get basically a 3-in-1 connector, because normally you'd have to have one connector for the high speed stuff that's like designed for differential high speed signals, and then another one maybe for the power connectivity, and then maybe another one if you have high voltages coming through. Compare this to the 2x20 connector on the Raspberry Pi Classic and other single board computers. You're going to have this extra height. Like this is the slimmest connectivity you can get. It's still like 8-10 millimeters high. And also every time you remove it, you risk bending the pins, which kind of sucks. So one of the things that's nice about this connector is it's designed specifically for, the pins are inside, they're protected, and there's this groove so that when you plug it in, it only really like, there's no way to be off by one set of pins. So you're not gonna like crush the pins. And then when you remove it, as long as you remove them and place them parallel and flat, and you push down in the center, the connector is rated for at least 30 connections. And they even say like, try to be careful, try not to wedge it from side to side, but it will not fail instantly when you do that. So they're like, please try not to, but you can rock it a little bit back and forth. And I thought I'd actually just show the connector if we go on the overhead here. So this is the compute module, and you can see like this is each 100 pin connector, very, very fine pitch. Doesn't take up a lot of room, but does allow a lot of expansion. And then, line it here, and then I'll plug it in. So when you plug it in, you can sort of feel it kind of clicks into place before even the contacts make contact. And then there's this really nice, satisfying, like soft plug. You can feel it tactily when it's plugged in. It's connected in nicely. Okay. Where were we? Okay. So, actually, sorry. Can you go back one more? So one thing to note is, I meant to the overhead. Apologies. I wanted I remember why. I want to show the height. So I think this is like the 2 millimeter height. So the height of the connector can vary. You have both the uh, socket and plug side, and so you can mate and match different heights for one side of the connector, and it can be as low as 1.5 millimeter or as high as 4 millimeters. Although note, not every pinout is available in every stacking height, so you might have to have like more pins if you want. Like the higher you go, it looks like they're like, we don't have everything in the 4.0. You only have like 50 or higher. Probably also because you have to have mechanical stability for those heights. And this is just showing, this is like a little diagram that shows the variations in height. So 4 millimeters is like quite high. You can definitely get a lot of components, inductors, maybe even a USB connector underneath there. They also have a shielded version, which has ground shielding connection. Although with that one, it doesn't have all the heights, only has 1.5 and 3 millimeters. You can also use this connector with FPCs. So if you want a flex cable, they do tell you like, here's how you do the stiffener in order to be able to connect from an FPC to a circuit board. Although, to be honest, we've seen these mostly with PCB to PCB designs. And when I was thinking about like how to describe like these connectors and how we see them on these really high quality boards from Intel and Raspberry Pi, and I think of it kind of like the YKK zippers that probably have on your nice coats or your nice jeans or your nice dresses. If you have $100 board or even more expensive circuit board or design, and you use you go with a bad connector, you save 50 cents, but then like somebody plugs in wrong and like shears off the connector or like crushes one of the pins, the board is now useless. And connectors are a really big failure point. So having a good quality connector is worth the investment, so that you don't end up by having someone accidentally try to plug something backwards or they don't have it lined up correctly. Doesn't actually like destroy, because you can easily destroy both sides of the connector if you don't have a good one. This one is designed specifically, even beginners can use it. I think that's why Raspberry Pi picked it, and why Intel Edison uses it is your maker board, so people who are not super experienced engineers. Easy to line up, easy to insert, easy to remove, lots of cycles, but has that high density for use with high power and high current and high speed signals. And there is stock key. So this is the DF40F, which I think is a higher temperature version, but the family is quite large, with a lot of different sizes, pinouts, heights, etc. So you pick the one you need, and go to town. Enjoy using this to mate and connect complicated boards together with very slim heights.
And I'm gonna play video, and then we'll get off to new products over that.
Discover the DF40F series from Hirose, a leading solution in floating board-to-board connectors. Expertly combining a compact design with unmatched performance, it's the connector of choice for forward-thinking platforms. Let's explore the standout features of the DF40F series. It uniquely adapts to misalignments in X and Y directions, thanks to its innovative floating design with a range of plus or minus 0.3 millimeters. With its slim 0.4 millimeters pitch and 3.68 millimeters width, this connector is a testament to space efficiency. It's compatible with the DF40T, allowing for versatile stacking height options from 3.5 to 6.0 millimeters. Designed with automotive applications in mind, it can endure temperatures up to 125 degrees Celsius. Need speed? The DF40F delivers. It supports data rates like PCIe Gen 4 at 16 gigabits per second transmission. From automotive applications to medical tech, wearables, notebooks, tablets, and portable gaming devices, the DF40F series ensures versatile and dependable connections. Stay ahead of the curve with the DF40F series connector. For deeper insights, visit and subscribe to our YouTube channel, Hirose Electric, Connecting the Future.
On MPI.
All right, don't forget the code is Neo RGB. There's a bunch of free stuff. Let's kick it off with programs.
New, 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 new.
Alrighty, what's up?
Okay, we've got this ESP32 S3 Box 3B, which is a version of popular S3 box. It's like it got a display and it's got a little case and it's got a thingy it plugs into. This is just a lower cost version that doesn't come with sensors. So we have a slightly more expensive one that comes with sensors, and this one still has the box, ESP32 S3 box, and the stand, but doesn't have the extra sensors. Sign up, we'll have it in stock soon. We also have coming soon 2 versions of our Itsy Bitsy ESP32. We've designed this many, many years ago, but during the part shortage, we weren't able to get it out the door. But now it lives again, clearing out my long to-do list. So this is an Itsy Bitsy size board. So it's got 20 GPIO and power pins. Micro USB, because I want it to be compatible with the other Itsy Bitsy boards in case you have an enclosure. You can swap out whichever one you want. I don't want to have, maybe I'll make a version with USB-C later. On the bottom, it has a USB-C, USB to serial converter chip, and some markings and alternate battery input if desired. We also have a version with a WFL connector designed by Hiroshi, by the way, in case you're wondering. There's a STEMMA QT port on the top, NeoPixel on both of them, user button, reset button, and then auto reset circuitry. This is really great for very small IoT projects that need ESP32, which has Wi-Fi, Bluetooth Classic, Bluetooth Low Energy. We support it in CircuitPython, has great Arduino support. There's also MicroPython support and a lot of other chips as well. The ESP32 is like a very standardized chip. What's really nice about this board is it's got very, very good low power capability. I just tested it before the show. 10 microamps in deep sleep, which is like incredibly low. It's as low as the ESP32 can get. So by kind of designing this in a nice way, using a good regulator on it, you could definitely use this for very low power IoT projects or any project where you just need more pins than a cutie pie, but you don't need as many as a feather. And there's also one pin that's shifted up to 5 volts, so great for NeoPixel projects.
All right. And then this is
Parts?
the
Yeah, and the bottom is the same, just this one has a WFL connector. Okay, next up. This is not 100 bags, but this product is for 100 bags. We've been using a heat sealer to ship products because they're less likely to accidentally open. They're sealed, they're faster, they get auto barcoded. We love our heat sealer, but we still have a lot of these bags left over because we had to buy a lot of them a couple years ago. And we still use them for some products, but we still have a lot, and we would like to sell them to you because some people want them. So if you would like 100 of these adorable 2 by 3 inch approximately zip top anti-static bags, you can now pick them up at packs of 100 for a couple bucks a piece. It's a really good deal. Help us clear out our inventory, and you can reuse them as many times as you like. Great for storing little electronic parts. I'll say I store my prototypes in these little bags.
Okay, next up.
Next up, there's a revision for the Flora NeoPixels sheet. So for a very long time, we were using the WS2811S, which was the first version of the all-in-one NeoPixel LED. And what's cool about that chip is it can handle up to 9-volt DC power, but that chip is pretty much discontinued. So now we've changed out for the SK6812, which is our standard NeoPixel compatible LED. This is the same size, same pinout, same shape, same everything. The only difference is you can no longer use it with voltages above 5.7, 5.5 volts. So sorry if you were happening to power your projects from 6 to 9 volts, you can't do that anymore without a regulator or a buck converter. But in exchange, because I'm no longer using a chip that I have to, LED chip I have to chase after, the price is lower. So I'll drop the price. This is a great deal if you want to have little sewable LEDs. Get them in a sheet, just pop them out and trim them yourself.
Okay, and then next up to start the show, besides you, Lady, our team, our staff, and everybody make the thing go is...
Yay, it's the Neo RGB stemma board. This is a board I designed for myself because I was so tired of wiring up analog RGB LED strips with transistors and resistors and power connectors and like whatever. I want to make it really easy to control analog LED strips. That's LED strips that don't have neopixels in them. A lot of them use they use 12 volts, or even higher, but 12 volts is the most popular. And so now I have a board where you have neopixel signal in, like your standard neopixel that comes from any microcontroller or even a Raspberry Pi these days. And on the output, you have 3 common anode RGB channels, plus power and ground. You connect to the terminal block, and it acts like a single, very, very bright, very large neopixel. You can also use this with anytime you have like an LED array that has PWMable inputs. This will basically do the PWMable control, 8 bits per channel, 24 bits total, and then you just treat it like a neopixel. So, again, wonderful if you have analog neon or LED strip or something for some reason you want to, they're definitely for long extensions. They're cheaper than using neopixels, and you don't have individual LED control within the strip, but maybe you don't need that. Maybe you want to like do a single color for the entire thing. So I have a demo on overhead. So this is my standard Atmega 328 Metro Arduino compatible, and I'm powering it from 9 volt here. So this is 9 volt power. I connect the red wire to the stemma board from VN, so it's 9 volts, ground to ground, and then the neopixel signal. It thinks it's connected to a single neopixel, pin 6. This is a bright power LED telling you that the power is good. You can barely see it because it's only one LED, but there is a little bit of blinking going on the signal red LED over here. And then you just use the terminal screw block to connect red, green, blue, and then this black wire is VN, so it's the 12 volt power. And then this just acts like a neopixel, it's doing the neopixel swirl. So it's great because this can handle 3 amps per channel up to 16 volts. So if you have like a gigantic star RGB LED, or again, like you have a gigantic plate or analog LED strips, and you don't have to be RGB LED strips. If you have white, like cool, warm, or natural white, or sometimes there's LED strips that are analog that have color mixing, so you can change from cool to warm to neutral white. You could basically have this act as if it was a neopixel, and again, make it a lot easier to control. If you're using more than 2 amps total, recommend not going through the JST-PH, just go through the terminal block. So you just power directly from the terminal block here, and you can control, again, 9 amps total between all 3 channels. One thing I will mention is that if you're using RGBW LED strip, this only supports 3 channels. I haven't quite found a chip that supports 4 channels yet that is NeoPixel compatible. So you have a choice of either just controlling 3 of the channels, or there is an output pin here if you want to chain. You could connect the 4th channel on a second one of these and then just control it as if it was the second neopixel afterwards. You'd have to do the logic for it. You treat it as 2 neopixels. The first one is RGB and the second one is just W. But I'll let or sometimes, again, some strips have 5 channels. Again, you'd use 2 of these, 1 for each set of 3. So I think this will make wiring a lot easier for people, definitely make my demos a lot faster. So hopefully folks enjoy it. I know Erin, who does a lot of NeoPixel projects, has already been excited. She's like, yay, I can't wait to use this to already simplify some wiring on a project I did for a tiki bar.
And that's new products.
New.
Okay, don't forget the code is NeoRGB. We're gonna do some top secret, then we're gonna do some questions. You can jump them in Discord. Let's do some top secret. All right, Ladyada, what is this?
This is the new Itsy Bitsy ESP32. I designed this board in 2020. So this is one of those boards that's like, oh, part shortage is over. Let's try to get back to it. So we just got these assembled, and they're double-sided. They've got the USB serial converter on this side, ESP module with 8 megabytes of flash, 2 megabytes of PS1 on the top. Plug it into the tester, and then we're using a Pico using USB to serial to do the programming. let's give it a second. And it flashes the file. You can see on the computer, it's flashing it over USB to serial. So it's doing USB host to the WCH9102 chip to program the ESP32. And then in a few seconds, it's going to finish the test. And then you'll see the test complete. 34, 35, 36. Okay, so now it's going to test all the pins. Oh, and this one is not passing. Okay, then it's fine. You just have to hold it down 31 seconds later, and then this board is done being tested. And then when you reset it, it does a little nice rainbow glow. So this has passed test, and we'll be able to get it into store real soon.
All right, and then you're making some stuff.
Okay, so we've talked about the desk of Ladyada, this TCRT 1000 optical reflective sensor. That's a right angle. It's right. Maybe if you duck your head down, you can see the two things sticking out, the right angle style. And then this has potentiometer. You can change the current going through the sensor.
What else?
And then, I was thinking, because I just did this Neo RGB, maybe folks want to just make something NeoPixel, like a single LED that doesn't need the high current pass transistors. So I made a breakout for this WS2811F chip. It's like basically like a NeoPixel on a chip. You can connect any LED you like, and I made a little breadboard, friendly friend.
All right. That's top secret for the week.
Yeah, it's something great.
Okay. We are going to roll right into questions. We have a couple lined up right away. Let's get right to it. Okay. First up, Ladyada. Is it possible to make a DIY solder flow at home? Asking for a friend who's really into PCBs.
Well, you can do like a hot plate if you want to just reflow boards. If you're looking for like a solder reflow, selective solder machine, that's a lot harder. But you can get solder pots, and you can dip stuff into them, so like you can kind of sort of fake it.
Okay. Folks are talking about this in the chat. Can you make the Memento take multi label pics from the far focus and to close focus and have CircuitPython combine all the pics to a full focus picture? You could. It'd probably be like super slow.
It's just so
because
slow.
you need a computer.
I would just use a computer. It's really really
Let's talk about that. Eventually, I mean, Turing compatible computer. Yes,
well,
you could.
yeah. I mean, a Raspberry Pi could do it, but I meant
Okay.
that's tough.
Mesh Taxic seems to be the talk for the last couple of months. Seems Adafruit well suited for this niche. Any plans to further support for it? Would prefer Adafruit versus them.
I have no idea what Meshtastic is. I'm
Okay.
so sorry. Is that like a? I don't know. Sorry.
Next up, how would you measure the pulse width and cycle time of a digital signal, like frequency and duty cycle of a PWM signal? Can it be done with RPI and Python, or is it something for a micro? What is the interface for that kind of input? Want to read the values programmatically rather than use an oscilloscope or D?
Yeah, you need a frequency counter. So you definitely pop. I mean, there's some chips that can do it, but you probably want to use a microcontroller with like a counter input. It's actually quite a tough problem because you have to make sure that the counter can handle the frequency that you're looking at. Might be a good one to post in the forums, maybe. But I think definitely you'd want either customized chips or program a microcontroller.
Okay, Meshtastic is a LoRa thing.
Well, I hope it's a replacement for Things Network, because Things Network has not been very happy about people with single, if you have a single channel LoRa device, they're like not into it. So I'll take a look. I've been out of touch with the LoRa stuff.
Okay, we'll look into it.
Okay.
Itsy Bitsy 30 ESP32. What is the voltage range for the bat pin? Possible to power various 3XAA or AAA, 5.5-ish volts on the go.
Yeah, it goes into the RT9080 through a Chucky diode. So you definitely want to give it about 3.6 volts to about 6 volts. So anywhere in between there.
Okay, question for Adafruit. Does Adafruit have something that can efficiently limit current to stalled servos drawing too much current? Would prefer them to stall weakly or temporarily stop. And fixing my shoddy code will enable more pin aggressively, but electronics hardware protection would be good. Should I use polyfuse or current limiting IC or something else? Got modules for this scenario. Making a servo-based wood tile display with 192 servos, 12 groups of 16 servos, manage to burn out MOSFETs, a 12 knockoff PCA 96835, 16 channel servo control boards. Serves me right for not buying from Adafruit, which comes from BP.
Well, I think that's not relevant. I mean,
yeah.
Okay. Yeah, current limiting a servo. Yeah, servos can draw up to 2 amps. They definitely go to town. Yeah, that is a challenge because you want to individually control. You definitely want. There are current limiting ICs. There's e-fuses, and they'll current limit, and a lot of them even have a thing with the auto retry, or they'll just like reduce the current to a certain amount. So I think I did a great search on e-fuses, but check Digi for e-fuse chips, and I'm positive they have one that's 5 volt, 2 amp. I just don't know off the top of my head.
Yeah, just Lady on Sunday. Just fun question. Did you watch Super Bowl or just busy with shelf stuff? Yeah, we have a Adafruit and kids, so we
Yeah.
don't really. I understand that it was in
I would
overtime,
love to. So, yeah.
and I understand there was a lot of like celebrity stuff, and you know, I do think that the Super Bowl is a good opportunity for a big chunk of at least in the U.S. for people to come together. I know there was a tragedy today with a. This is why we can't have nice things. There was a shooting at a parade,
Ooh.
a celebration of Super Bowl today.
That's messed up.
But generally speaking, you know, sporting events and just like humans like to come together and celebrate something. So, and I do like the friendly competition, and you know the teams. You know, everyone's at their best, and it's a very American thing, and it's nice to see everyone come together. So, as far as like the radiation of that, we, you know, you can't avoid it. There's Super Bowl commercials and there's all this stuff, but you know there is a general feeling in the nation around Super Bowl. It's like, hey, everyone's kind of watching this thing and doing this. You know, we were busy with work and stuff, but it is nice that everyone wants to come together. And aside from that, I think we have one last question.
Okay.
The illuminated push button instructions say the forward voltage on the LED is about 2.2 volts with a connected to 20 or 1,000 ohm resistor. Is that necessary? A 2 volt LED would usually take 56 ohm.
You can go lesser, but I like to give people, because I don't know what voltage you're connecting to. So if you want to calculate it out, you know, I think, you know, keep it to like 10 to 15, 20 milliamps. But it's always great to start with about 1K. No matter what your voltage is, you know, you won't destroy it, and then adjust as necessary. So
Yeah.
not too bright.
Them's the questions.
All right.
That's our show tonight. Thank you so much, everybody. The code is NeoRGB. You saw why. Get one of these.
10% off.
And don't forget, there's free stuff. Special thanks to Carb behind the scenes, running stuff in the Adafruit Community Smart Publishing side while we do the show. Thank you. We'll see everybody next week. This has been an Adafruit production. We'll see you
Right on time.
on Wednesday next week. Bye bye.
Hey, have a great week.
Here's your mom, Zena.
Bye.
Bye.